Hello, and thank you for selecting the California Enterprise Architecture Framework Views presentation. This presentation is a brief overview of the California Enterprise Architecture Views, the fourth of four core building blocks of our statewide EA framework. This presentation is approximately 30 minutes and covers the high-level information presented in much further detail in the full-length Views document located on this same webpage. Views are the graphical models and diagrams the framework refers to within enterprise architecture programs that are a fundamental resource to manage and communicate an organization's architectural concepts. Since stakeholder perspectives often vary depending on their goal orientation, and since their view of an architectural concept changes depending on the viewpoint from which they are observing, architects use graphics to achieve common understanding. This way, regardless of the stakeholder or perspective, the chances of having a more informed and collaborative conversation is possible. Enterprise architecture programs can utilize graphical views to communicate baseline capabilities and resources, develop plausible future operating scenarios to review needed changes, describe relationships of EA components within organizational domains, and capture architectural patterns in business-driven solution designs. Views present a perspective from a viewpoint or unique position. In this picture, our view is of Capitol Mall in Sacramento, California. Our viewpoint is from the steps of the California State Capitol building. Trees, streets, grass, tall buildings, and the infamous gold I Street Bridge have an affiliation to making up the view of Sacramento's Capitol Mall from this viewpoint. The view provides common information regardless of the person, their background, or their knowledge of the area. Views depict multiple aspects of an organization components in a simplified and more attractive format. In the same way that the elements in the picture provide context of Capitol Mall, integrated views of an organization's strategic goals, missions, support services, and information systems together provide context to an architectural scope. The enterprise architect is the primary role to formulate and present these views. The framework discusses the basic architectural views and concept around the idea that graphical representations of organizational components from specific perspectives provide a common understanding across business and technology domains and cross-functional teams to significantly increase the chance of achieving results. Graphical tools help EA programs to stay integrated into the decision-making processes of organizational management by helping translate architectural components into easily understood documentation more quickly. Models and diagrams are a central part of activities that lead up to the deployment of good systems. Architects use them to communicate the desired structure and behavior of systems and build them to visualize and control systems architecture. Some benefits of model and diagram language are to reduce the likelihood of adversely impactful decisions, gain and maintain executive sponsors and resources for the EA program, communicate high-level management-friendly views of architectural scope, show the boundaries of the architectural scope, and combine artifacts into actionable information for managing and decision-making. This is a sample diagram that provides a visual representation of a set of technology components that together satisfy a specific need. It may represent a current or desired view from a systems integration viewpoint. Characteristics of this graphic are: it's conceptually high level, it provides a context of system-relevant linkages and actors, it illustrates the general flow of technology component information in the system, and it shows architectural boundaries. Benefits from its use are: it's easy to understand, it's communication friendly, and it presents opportunities to identify gaps and/or adverse impacts. Depending on the level of detail required or the viewpoint from which additional information is needed, architects can expand architectural domains from this conceptual level view. With additional analysis, it can be further decomposed to illustrate more design specificity. Artifacts provided in the framework can be leveraged for a variety of uses. Fundamental views discussed within the framework are the current and future state views of architectural scope, followed by the transformation sequence or roadmap between them. The roadmap and views provide a picture of the architecture in terms of what currently exists, is planned for, and which initiatives constitute a roadmap to transition to the future state. Since government operations and strategic goals are not static, these work products should be updated periodically to reflect new realities and changing directions. The framework recommends creating current and future state views that focus on a manageable number of key business outcomes and the underlying segments to provide quick value and gain support. This incremental approach allows the EA program to evolve over time. The framework provides views of reference that may expose opportunities for cross-program initiatives to share common services and provide interoperable technology solutions for similar business goals. The EA statewide repository includes, but is not limited to, system architecture implementation patterns, common design patterns and themes, and common business planning scenarios. The framework promotes placing the development of the enterprise architecture using a segment approach at the forefront. Segments can be defined either organizationally, for example, a business unit, or functionally, for example, information security. Segment analysis focuses on a service area or business unit within a department or agency or between programs. The result is a detailed, results-oriented baseline and target architecture as well as transitional strategies. By doing this, value is observed in these ways. It provides value more quickly and helps to gain executive support for a sustained EA program. It facilitates incremental development of an agency's enterprise architecture, and it allows identification of cross-cutting segments that serve several lines of business within or between programs that support similar mission areas. 3 foundational views are presented: current, future, and target state architecture views. Current state views represent the motivational elements pertaining to baseline requirements and constraints. They're important to an enterprise in that they establish or verify what business and technology resources are being used to support the achievement of strategic goals. This becomes a reference baseline, much like an inventory, that then supports planning for the future architecture. It is in the documenting of the current architecture components, a view of the architectural scope emerges that reveals associations, dependencies, and performance gaps between the business's requirements and current capabilities. It is in the collection of the aggregated current state segment documents that a view of the enterprise exposes strategic gaps. Future state views represent a modified 2B state of the current state baseline within the context of the strategic direction and operating model. They also identify the motivational elements pertaining to the future state and relate them to other architecture elements. The target architecture is an important part of the future state vision. It enables departments to realize synergies and efficiencies across diverse business units and allows for business unit autonomy when it's the best course of action. Target and future state architecture are often used synonymously. The key difference between them is that the future state includes more of the desired experience, whereas the target architecture is exclusive of organization components. A target architecture should serve as a model, communication, and key input to creating the enterprise's future vision. Depict how architectural patterns can be used as building blocks in cross-program solution design and shared services and systems. The target architecture vision represents a long-term vision for evolving the organization's enterprise architecture. It cannot be realized quickly or without collaboration, core process ownership, and a long-term support. Therefore, CEAF recommends EA programs focus on department-level business operations before advancing to agency-level standardization. To focus only on the enterprise may prevent them from ever achieving the future state. It is expected for transformation strategies to execute many projects before the enterprise target architecture can be achieved. Therefore, an individual transformation initiative may result in the need for an intermediate architecture. The following steps provide guidance to develop and align implementation strategies of transformation initiatives as well as help facilitate maturity in the organization's enterprise architecture. Using architectural drivers, dependencies, and the capabilities of ongoing transformation initiatives to determine the architecture areas for which to create standardized solutions. Integrate design patterns into initiatives to guide solution efforts, meaning to harvest reusable assets based on best practice implementations, the patterns for common capabilities. Collaborate with technology service providers to enhance the organization's capabilities to provide the above implementation patterns as standard services and multi-tenant consumers, and continually collaborate and analyze other organizations' transformation roadmaps to identify and undertake cross-program initiatives that develop shared solutions and ultimately cost. Motivation are important elements of enterprise architecture that is the basis for why the architecture is constructed the way that it is. Motivation elements are the actual impetuses or inspirations and the forces that together affect the enterprise architecture. They drive the organization's domain capabilities and provide better integrated views across organizational and functional segments. Motivation also manifests itself in work activities and work products that drive architectural decisions. For example, stakeholder interviews, application assessments, state regulations are all motivations that influence future state architectures. The elements of motivation that are considered are critical to enterprise architecture programs in their day-to-day work. Not only do motivating aspects inform progress, but they also provide caveats or constraints to prevent over-engineering. Cross-domain components are aspects of the enterprise architecture operating in multiple domains rather than separately, such as security, skills, performance, and interoperability. The terms used suggest that these areas are enterprise architecture domains of their own. However, closer examination reveals that they are present in multiple domains, hence the label cross-domain. The framework identifies that motivation and cross-domain elements are discussed in each engagement, each domain, each initiative, rather than individually and separately. There are 5 architectural domains foundational to enterprise architecture work. An enterprise's strategic, business, information, application, and technological domains were identified in the Framework Digest building block and are further explored here. Each of these domain views contribute to the awareness and support to the relationship between an organization's operating model components. They cannot efficiently and effectively exist without each other in the delivery of an organization's mission and tasked goals. Strategic views driven by motivation are high-level direction perspectives that an enterprise or organization segment sets for itself. Strategic views support strategic planning efforts by presenting linkages of organizational domains and developing longer-range future state operating scenarios and goals. They also highlight impacts to business and technology roles and activities in achieving the goal within a given scenario. Through the strategic planning process, one future state scenario is selected to represent what the enterprise or segment is going to do. Organizations then adjust to accommodate its undertaking, and EA artifacts should be updated and officially published as changes are made to the strategic plan. EA programs can assist in the formation of strategic planning and in doing so deliver value that results in an outcome within an operating scenario that is discernible and measurable and does not reduce the enterprise's flexibility so much that the operating scenarios cannot be pursued. Examples of common EA artifacts that support strategic planning activities are identified in the EA statewide repository as well as the EA community for strategic view contributions. Understanding the organization's business should be first and foremost within EA programs. The CEAF places significant emphasis on the importance of understanding and accurately representing the organization's business architecture. Ultimately, the technology domains operating within organizations run the risk of under or over delivering IT services if understanding of business services and processes are not clearly and concisely illustrated in a manner understood by all. Within business views, context and overlaying processes show the parts of business capabilities in a format that can be further decomposed and interrelated with other processes to show relationships. With a solid understanding of business context, architects can then further identify inputs, controls, outputs, and perform assessments to illustrate complete business capability activities. Examples of common supporting artifacts that contribute to the understanding of EA components in the business architecture domain are identified in the EA statewide repository as well as the EA community for business architecture-focused contributions. Information architecture describes the fundamental organization of the data and information that support business processes and application systems. These views deal with the fundamental organization of data and information and the principles guiding their detailed design and evolution. As such, information architecture in the EA context is at a high level and is mainly concerned with the overall coherence of data and information at the enterprise level. Artifacts include identifying information structures and flows, and in that, it's important that artifacts show not only what is in each system, but also how systems interact. Data can be analyzed using different methods, and depending on how the resulting information is intended to be used, should reflect the processes that transform data within the system. Data flows can be decomposed from a very high level to a basic process level to several sub-levels that examine each process in greater detail. The level of detail needed is dependent on the architect's participation and purpose of the artifact. Examples of common supporting artifacts that contribute to the understanding of EA components and the information architecture domain are identified in the EA statewide repository as well as the EA community for information architecture focused contributions. Application views can describe the structure and behavior of the major kinds of application systems and their key components necessary to support business process information. These views represent how applications interact with each other, how users interact with them, and what data get transformed to deliver output. Within the framework, application architecture is concerned with managing how multiple applications are positioned to work together to support the business. Architects should not be concerned with the detailed design of application systems right away. Rather, the goal here is to define enterprise-relevant application systems and what they need to do in order to manage data and present information. Architects can create this view through combining smaller scoped engagements. Then further decomposition can be performed as needed. Examples of common supporting artifacts that contribute to the understanding of EA components in the application architecture domain are identified in the EA statewide repository as well as the EA community for application architecture focused contributions. Technology views focus on the infrastructure level components and services necessary to provide integrated infrastructure support of the business. They describe the logical software, hardware, and communication capabilities that are required to support the deployment of applications and data. They also describe the structure and interaction of the platform services provided by these resources and networks and the technology components that enable these platform services. Examples of common supporting artifacts that contribute to the understanding of EA components in the technology architecture domain are identified in the EA statewide repository as well as the EA community for technology architecture focused contributions. The framework fosters architectural designs that promote the use of patterns. Three types of useful patterns are distinct, common, and core modeling elements in both business and technology of architecture scope. Reference models, also referred to as implementation architectures, which are template technology designs for a specific architectural scope, and common business scenarios, which are functions, processes, or activities exercised in very similar ways by most state departments or agencies. Information technology patterns identify how a set of technology elements should interact and be deployed to best deliver a solution that supports an application or system. They're used to define how technology elements work best together to deliver a specific experience in a cohesive and interoperable manner. The framework information technology patterns are based on state-defined architecture implementations and are expected to provide many benefits. 4 of these benefits are indicated here. To ensure individual IT elements and corresponding standards are interoperable and work together in the context of a larger application or system, improve data consolidation and standardization and reduce redundancies, reduce technical complexity within departments and across agencies, and improve deployment speed and reduce support and maintenance costs. The framework recommends a bottom-up approach for creating IT patterns. Using the framework, departments or agencies can create implementation patterns based on their projects, recently created, or modernized application systems. When architects recognize their organization's technology patterns, they can formulate the architecture that represents the whole of the enterprise and then use them when referring to the start of a new initiative. Beyond the organization border, those patterns may be reviewed for consideration as a cross-program or statewide standard. Variances in modeling can be categorized as distinct, common, and core elements of the architecture scope and exist in both business and technology domain views. For instance, when considering business operations, the distinction helps analyze existing business processes. They're identified as distinct, common, and core processes based on the business drivers and strategic goals. When considering technical operations, the distinction helps analyze current state architecture. They're identified as distinct, common, and core infrastructure services based on business operations. Distinct modeling elements are elements that are specific to a capability, process, or segment with little to no interaction or coordination with other architectures. Common modeling elements are elements that are common to some, not all, capability, process, or segment. Core modeling elements are elements that are common to the entire organization architecture, usually shared enterprise applications. The goal with these classifications is not to impose that everything must be standardized, centralized, or even shared, but rather decisions can be made as to which solutions should and shouldn't be treated as such. A reference model is a template architectural design for a specific architectural subject area. It's an abstraction of multiple solution architectures designed and implemented to solve a specific and recurring business or technical problem. They incorporate knowledge, patterns, and best practices gained from successful implementations and serve as a key input when creating target architectures. They guide and constrain instances of multiple architectures and solutions. Standards play a significant role in reference models to augment and drive the models describing how specific products can be combined to deliver a cohesive, effective, and sustainable solution. The standards should promote controlled innovation to balance advancements in technology with an organized, business-oriented technology planning and governance effort. The sample image here provides a contextual architectural view of a service-oriented architecture reference model pattern. From the viewpoint of the architect, the components identified are essential to the context of implementing a sustainable SOA solution. The reference model is a repeatable implementation pattern and may be perceived as a standard design. The framework considers reference models as key contributors to information technology solution implementations. Today, state IT initiatives often identify with the following 8 common models. Each of these logical view models are documented and in the statewide EA repository. Cloud computing, identity and access management, business intelligence, master data management, service-oriented architecture, enterprise application integration, enterprise content management, and e-government. Common business scenarios is the third architectural pattern incorporated into the framework. These 4 common business scenarios exist across departments and agencies in some form. They are project planning, EA program planning, governance planning, and workstream transformation planning. As mentioned in the program and portfolio portions of the framework, EA programs are more likely to provide consistent services in these situations. These common scenarios are widespread and demand a higher frequency of EA consultation that lends to more consistent architectural service patterns. The statewide repository contains specified artifacts that can be used to facilitate meaningful analysis by architects working in these scenarios. First, project planning. Regardless of the project planning framework methodology or oversight procedures of state IT initiatives, enterprise architecture plays a significant role in the architectural planning of the proposed project solution. Architects facilitate and support a common understanding of needs and help formulate recommendations to meet those needs. They contribute to the development of an action plan that's grounded in an integrated view of not just technology planning, but the broader spectrum of motivation elements, business, application portfolio, security, infrastructure, capital, and human capital planning. Second is EA program planning. Successfully delivering enterprise architecture services described in the framework is nearly impossible without the establishment of a dedicated EA team to apply the methods and framework to mission tasks. Establishing an EA program, much like other concentrated functions within organizations, call for components that should be considered in relative sequence. A program development roadmap is provided for consideration in communicating the needs of establishing an EA program within an organization. Third is governance planning. EA programs actively participate in the organization's governance activities at both the enterprise and project levels as architectural advisors and stewards. The governance provided by EA programs requires that the strategic and investment decisions of organizational leaders is complementary to the future state architecture. Architects advise the organization's governing bodies based on knowledge of EA components that have potential impacts to mission, purpose, direction, priorities, and strategies. This role is not to be confused with oversight, but rather informational to the decision-making body. In project-focused governance, the relationship between the solution architecture and EA and the need to provide governance, oversight, and/or facilitation in the solution design requires the tactical and consistent involvement of the EA program. EA involvement in solution architecture design and consultation is also intended to assist the specific project management team to achieve predictable project success. It helps balance project management and technical leadership, a balance that is key for transformation project success. And fourth, workstream transformation planning. With the fast-paced advancement of technology and service delivery trends, architects may find they need to meet professional service demands with faster and narrower analysis cycles to provide informed analytical inputs more quickly. The organization's urgency to react may not allow time to perform traditional analysis and design activities, however, maintaining expected value. In these situations, architects can be prepared with a toolkit of purposeful artifacts that support the facilitation of these fast-paced transformation initiatives. Whether transformation is capability or technology focused, Architects should be poised and ready to consult, pulling on a finite set of artifacts that drive to conclusions quickly. The California Enterprise Architecture Framework Views full presentation, as well as the Views document, can be referenced and downloaded from the Office of Enterprise Architecture homepage on the CDT website. Your questions, comments, and collaboration are welcome and encouraged. Please check out the EA Communities Forum located in CDT's Communities portal. Thank you.